Okay, so ready to dive in? Today, we're taking a deep, deep look at machine guards and shields, all kinds of them.
Sounds good to me.
Yeah. And, you shared some really in-depth material from PowerSafe Automation.
Yeah.
And, our goal here is to really kind of extract that critical information, those real nuggets of, keeping those machinists safe.
Right.
And, we're going to go through a bunch of different types of guards and shields for all sorts of different machines and really focus on, how do they actually protect against those specific dangers?
Yeah, because they're kind of the unsung heroes of the machine shop.
Right.
I mean, a lot of people don't think about machine guarding.
Right.
But they're so critical to preventing those really serious injuries.
Yeah.
And it's really fascinating when you start to kind of dig into, the engineering and the cleverness behind the designs.
Yeah.
Because it's not just about putting up a barrier. It's about making those barriers work for machinists, making them easy to use, making them practical.
Right.
So that they're not just a hindrance.
Right. Yeah, because, we've all seen those situations where people bypass safety protocols for the sake of expediency.
Exactly.
So it's so important. And that's really what makes this so critical for our listeners, understanding this. It's not just checking a box.
Right.
It's not just about compliance. It's about fostering that workplace environment where every machinist can operate safely and go home in one piece at the end of the day.
Absolutely.
So whether, our listeners are working with these machines directly or maybe just have a real deep interest in workplace safety in general.
Yeah.
We think this deep dive is really going to bring some of those aha moments, those real insights.
Yeah.
So let's jump right in, shall we? We've got a pretty comprehensive list of different machines to get through.
Absolutely.
And we're going to start with those manual lathes.
Okay, manual lathes. Yeah, these are a staple in so many machine shops.
Right.
And, they present some pretty unique hazards, right?
Yeah.
The material that you've got here, it's really focused on chuck guards.
Yeah.
And full lathe guards.
Yeah.
Often you'll see that sort of orange aluminum frame with those clear polycarbonate panels.
Right. Those really stand out.
Yeah. What are your initial thoughts when you see that kind of setup?
Well, it strikes me the first thing that jumps out is just the thoughtful design.
Yes.
They've got the hinge and the sliding options, which, makes total sense depending on, the workspace, how the machinist needs to interact with it.
Yeah.
But then you see that safety switch, right?
Right.
And that jumps out at me because that's a serious approach to safety.
Yes.
Capable of handling up to 480 volts. That's for that primary operation, right?
Right.
And then they've got that authorized bypass key, which I thought was interesting for those secondary tasks. Like if you need to do some polishing or deburring, it's like, okay, we need to maintain those safety protocols, but we also don't want to completely shut down any necessary work.
Yeah.
And then even, they've got those optional vinyl strips to kind of contain that coolant, those chips.
Yeah.
It's like they've thought of everything, which is it's a nice touch. And even mentioning those specific brands like the Harding, the Jet, the Bailey, the Kent.
Right.
It's like, okay, these aren't just one size fits all solutions. These are tailored for specific types of machines.
Exactly. And I think if we zoom out a little bit and kind of connect that to the bigger picture, you can see how those features really address those inherent risks of lathe operation.
Yeah.
I mean, you've got those sharp metal shavings, those swarfs, so how they're coming off,
Right.
and the potential for cuts is huge. You've got the danger of getting pulled in or wrapped up, right? Clothing, a hand, anything getting caught in those rotating parts. And of course, the spraying of oil and coolant, flying chips, those are all hazards that we've got to address.
Right.
And one thing I noticed here, the reference to ANSI B11.6.
Yeah.
Now, ANSI, for those who don't know, that's the American National Standards Institute.
Okay.
And B11.6 is that specific guideline for lathe safety.
Okay.
So that's really important because it means that these guards are designed and built to meet those recognized industry standards.
Got it. So, we're moving along here, and up next we've got those milling machines.
Okay, milling machine.
Another really common sight in the machine shop.
Yeah.
And the material here describes this modular guarding system for both manual and CNC bed mills.
Right.
They've got those mounting options on the ram or on the head.
Yep.
What really stood out to you about this setup?
I think the key thing here is modularity, right? Because milling operations can vary so much. I mean, you're working with different size tools, different shapes of work pieces.
Right.
So having guards that can be easily adapted to those different setups is absolutely crucial, both for safety and for efficiency.
Right.
And I thought the articulating arms sounded really interesting.
Yeah.
Because they provide that flexibility. You know, the machinists need to be able to move around to get the job done. But at the same time, it's maintaining that protective area.
Right.
And like with the lathes, I mean, the primary goal here is to prevent those hazards, right? So we're talking about hot flying chips, entanglement with moving parts, cut, crush, shear points, all of that.
Yeah.
And again, we're seeing safety switches designed for different systems, right?
Yeah.
So you've got 110 volts AC for the power feed, and then up to 480 volts to interrupt that spindle motor.
Okay.
Again, really targeting those specific risks.
Right.
We're seeing familiar brands here too, Bridgeport, Jet. And the reference to ANSI B11.8 tells us that we're dealing with the specific safety standards for milling machines.
Got it. Got it. Yeah, I like that idea of the flexibility, you know?
Yeah.
Making those safety measures work without impeding the actual work.
Exactly.
So let's move on, shall we?
Let's do it.
We've got radial arm drills and drill presses up next.
Okay. Radial arm drills, drill presses.
These, you know, they present their own kind of unique safety considerations, wouldn't you say?
Absolutely. I mean, they look deceptively simple.
Yeah.
Right?
Yeah.
But there's a lot going on there.
Yeah.
The material that you've got, it's really highlighting those adjustable guards that can be mounted on the column of the drill or using a more universal pattern.
Okay.
And the main purpose here is to contain those sharp metal shavings that are produced during drilling.
Right.
I mean, think about it. You know, you're leaning in, you're operating this drill press. That guard is acting as that primary barrier, right? And the risk of cuts from those rotating drill bits, entanglement with the spindle or the chuck, those are significant. And it's important not to forget about that coolant spray, right?
Right.
Because that can create a really slippery floor.
It's true. Yeah.
And they mentioned the safety switches for brands like Jet and Delta, which is a great addition, you know, an extra layer of protection.
Yeah.
What's interesting is that for those larger radial arm drills, they're talking about additional safety measures.
Okay.
Things like safety mats that detect if someone's entering a hazardous area.
Right.
Or even physical guarding at the back of the machine.
Okay.
So it's really about scaling those safety protocols to the size and the potential risks of the equipment.
Right.
And the relevant standard here, again, is ANSI B11.8, which covers drilling machine safety.
Okay, great. So we're going to shift gears a little bit now.
Okay.
We're going to talk about those general shot presses.
Right, shot presses.
Yeah, and, you know, the material here is talking about those steel mesh or ballistic curtains.
Yep.
But notably, you know, initially it doesn't mention any safety switches.
Right, that's a good point.
So, you know, what do you think the reasoning behind that is?
Well, I think with shot presses, the main danger often comes from that sudden ejection of the material that's being pressed.
Yeah.
The fragments, you know, if something fails under pressure.
Right.
So those curtains are specifically designed to contain those projectiles, right? They need to be flexible because you're dealing with different part sizes, and they need to allow the operator to see what's happening.
Right.
And in many pressing operations, a safety switch that stops the machine cycle might not actually be the most effective way to prevent injury from that ejected material.
Okay.
However, I did notice that they do offer an option for point of operation guarding with the safety interlocked polycarbonate door for those smaller parts.
Right.
So it's not that safety switches aren't valuable. It's just that sometimes they might not be the most practical solution for the specific task.
Yeah, yeah.
And the reference here to ANSI B11, that provides that broad set of safety guidelines for presses.
Okay, great. So it's really about, you know, what's the most significant risk and designing that guard to mitigate that risk.
Exactly.
Okay, so up next we've got those bench grinders and buffers.
All right, bench grinders.
You know, they might seem a little less intimidating.
Yeah.
But there are some really important safety details here that we need to talk about.
Right. I mean, they might look simpler than a lathe.
Yeah.
But, you know, those bench grinders and buffers can cause some really serious injuries to the eyes, to the face, to the body.
Yeah.
You know, you've got flying debris.
Right.
You've got sparks from the grinding process.
Right.
And then the rotating abrasive wheels themselves.
Yeah. Yeah.
So those metal-framed polycarbonate shields, That's that first line of defense. And they do have the option for those side guards, which is great.
Yeah.
But the really, really crucial thing here is that they've got those specific recommendations for adjusting the tongue guard to within a 1/4 inch of the wheel.
Okay.
And the work rest to within an 1/8 inch.
Okay.
Now, those gaps might seem small, but they're vital to prevent the workpiece from getting caught.
Right.
Between the rest and the wheel, because that could actually cause the wheel to shatter.
Oh, wow.
Yeah.
Okay.
And the reference to ANSI B11 just underscores how important those precise adjustments are for safe operation.
Got it. Yeah, those tolerances,
Yeah.
they really highlight the need for that operator training
Yep,
and those regular checks.
Yeah.
Okay, so moving right along.
Moving right along.
We've got belt and disc sanders up next.
Right, belt and disc sanders.
Again, they've got those adjustable guards designed to cover any part of that sanding surface that's not being used.
Yep.
So what are those main hazards that we're dealing with here?
Well, with belt and disc sanders, you're working with those moving abrasive surfaces.
Right.
So you've got that risk of cuts, burns from friction, abrasions.
Right.
But they also emphasize the danger of nip points, which are those locations where the sanding belt or disc runs over the drive pulley.
Okay.
And those nip points can catch fingers, they can catch clothing.
Oh, wow.
Leading to entanglement, even amputation.
Wow, okay.
Yeah, so those adjustable guards are there to prevent accidental contact with those parts of the sander that aren't directly involved in that sanding operation.
All right.
And the reference here to ANSI B7.1, that's the specific one that deals with abrasive grinding and sanding equipment.
Got it. Okay, so we're going to move on to bandsaws now.
All right, bandsaws.
And it looks like the material makes a distinction between vertical bandsaws for shop use versus those for production environments.
Right.
So, what are those key differences in the guarding strategy?
Yeah, that's a good point. So for those vertical bandsaws designed for general shop use,
yeah,
the focus is really on a polycarbonate panel shield or blade guard that can be adjusted in multiple directions.
Okay.
And the main goal there is to prevent that accidental contact with the moving blade while you're feeding material into the saw.
Right.
I mean, that kind of contact can lead to cuts, lacerations, even amputation.
Right.
So it's serious stuff. And I noticed that those guards often have that high visibility orange edge, but they don't typically include a safety switch.
Okay.
And I think that probably reflects the fact that in a shop setting, you're cutting a lot of different materials.
Right.
Different shapes, different sizes, so you need to be able to adjust that guard frequently.
Makes sense.
And the relevant standard here, again, ANSI B11.N0 Note 2003, that's the one specific to bandsaw safety.
Got it. Got it. Okay, so for shop use, it's more about that direct physical barrier that can be easily adapted.
Right.
So what about those larger vertical bandsaws in those production settings?
Yeah, so in a production environment, you're often dealing with more standardized tasks,
right,
or a more defined working area.
Yeah.
So that allows for a more comprehensive and integrated safety system.
Okay.
So you'll often see safety light curtains positioned at the point of operation.
Right.
They create that invisible barrier, and if that barrier is broken, the machine stops immediately.
Okay.
And then you'll also have that physical guarding around the sides and the back of the machine.
Right.
So a very, comprehensive approach.
Yeah.
And that's designed to prevent cutting, shearing, entanglement hazards,
right,
while still allowing controlled access for things like removing chips, changing blades.
Right.
And another really critical safety feature in those production setups is the option for remote cycle start and emergency stop buttons.
Okay.
So you can be outside that immediate hazard zone,
right,
and still control the machine. And again, ANSI B 11.1 and S 2003, that's the guiding standard.
Okay, great. So, tailoring those safety measures
to the specific demands of that operational environment.
Exactly.
Okay, so horizontal bandsaws also seem to have that distinction between shop and production use in the material.
Right.
So let's start with those shop size equipment.
Okay, so for the shop size horizontal bandsaws, we're talking about those hinged guards with those polycarbonate panels and the vinyl strips.
Right.
And importantly, those guards are equipped with safety switches.
Okay.
So the polycarbonate provides that visibility, you can see what's happening, and those vinyl strips probably help to contain some of the smaller debris and adapt to different material thicknesses.
Right.
But the key here is that safety switch. It's designed to prevent the saw from operating if the guard is open.
Okay.
So that really reduces the risk of accidental contact with the blade.
Right.
Minimizes the potential for those shear and cut injuries.
Right.
And ultimately, protects against loss of limb.
Yeah.
And they use that high visibility safety yellow for those guards, which I think is a good idea.
Yeah.
Yeah.
It's that constant reminder of the hazard.
Right.
And as you might expect, the relevant ANSI standard is B11.2 in 2003.
Got it. Okay, so for the large, the big horizontal bandsaw systems, used in those high volume production,
Right.
it sounds like they've got even more sophisticated safety measures.
They do, yeah. In those high production settings,
Yeah.
you often see those more advanced safety technologies coming into play.
Yeah.
So they mentioned safety switch mats or laser scanners that are placed around those hazardous cutting and clamping areas.
Right.
And those systems can detect the presence of personnel.
Yeah.
And they'll automatically stop the machine if someone enters that danger zone.
Okay.
And then you've got those protective bollards, which provide that extra physical barrier.
Right.
Plus, they often have that solid physical guarding at the rear of the machine.
Okay.
And the remote blade start operator station, with that e-stop button on a pedestal, that ensures the operator's at a safe distance during those critical operational phases. And one detail I thought was really interesting is that they've designed these systems to allow hydraulic energy to remain active for blade changes.
Okay.
While the machine's otherwise safely interlocked.
Right. Yeah.
So they're really thinking about those maintenance protocols, those safety protocols during maintenance as well.
Right.
And the applicable standard there remains ANSI B11.DID Nishimile 2003.
It's amazing how they really integrate those safety measures into the whole workflow.
Absolutely.
Even thinking about that maintenance aspect.
Yeah.
Okay, so let's talk about surface grinder guards.
All right, surface grinders.
Yeah, and the material notes that these are typically those machine safety enclosures and often don't include those safety switches.
Right.
So what's the rationale behind that, do you think?
Well, it's interesting, right?
Yeah.
Because it kind of reflects the unique hazards of a surface grinder, especially those that are related to the grinding wheel itself.
Right.
So while there is a risk of nip points, cuts, burns from contact with moving parts, a much bigger concern is the potential for that grinding wheel to shatter or even explode.
Oh, wow.
Yeah. Due to internal defects, maybe problems with how the coolant's applied, or even applying too much force.
Right.
So the main function of that enclosure is to contain those potentially dangerous fragments.
Right.
And in this case, using those safety switches that interrupt the grinding cycle might not be the most effective way to address that risk of a wheel failure.
Okay, that makes sense.
And they also point out the hazard of objects being thrown if the magnetic chuck, which holds the workpiece, isn't properly activated.
Right.
And the references here, they've got two. They've got ANSI B7.1, which covers those safety requirements for the use, care, and protection of abrasive wheels.
Okay.
And then ANSI B11.9, which is specific to grinding machine safety.
Got it.
So again, very specialized safety considerations.
Yeah. So in that instance, it's really that robust physical barrier of the enclosure.
Right.
That's the main safety mechanism.
It's the primary protection.
Okay, great. So we're getting near the end of our list here.
Okay.
Next up is plate roller safety.
All right, plate rollers.
These machines, they're used for bending and forming metal.
Yeah.
They sound like they involve some serious force.
Absolutely. They generate some incredible forces.
Yeah.
And you've got those really powerful in-running nip points where the rollers meet.
Right.
So there's a real risk of crushing injuries there.
Wow.
Plus, you've got pinch points and entanglement hazards.
Okay.
So the safety solutions they're describing here include those custom-designed safety mats that are placed around the rollers.
Okay.
And they're monitored by a dedicated safety controller.
Right.
So if someone steps on a mat in that hazardous zone, the machine should automatically stop.
Okay.
And then they've got that pedestal-style two-hand operator control.
Right.
Which is really crucial.
Yeah.
It requires the operator to use both hands simultaneously to activate the rollers. So it keeps their hands away from those dangerous pinch points.
Right.
And then they've got those optional emergency rope pull stops that provide that extra readily accessible way to halt the machinery in case of emergency.
Right.
And the guiding safety standard for plate rollers is ASSI B11.12.
Okay, great. You know, that two-hand control system?
Yeah.
It's a classic.
It's a classic for a reason.
And it works.
It works.
Okay, so last but not least, we've got shear nip girding.
Right. Shear nip girding.
This sounds particularly focused on preventing that direct contact with the sharp blades of shears.
Yeah, and for good reason.
Yeah.
I mean, shearing machines, they're designed to cut, right?
Right.
So the potential for those severe cuts, lacerations, shear injuries, crushing, even amputations at that moving blade, it's really high.
Yeah.
So they use those high-strength round bar finger guards, also called nip guards, which are bolted directly at the point of operation to create that physical barrier that prevents hands from getting into that danger zone.
Okay.
And it's also really important to have guards on the sides of the machine to protect against hazards from those exposed moving components like gears, sprockets, chains, all those things. And then for that real comprehensive safety, you'll often see custom perimeter guarding with safety gates that are interlocked with safety switches and tied into that emergency stop circuit.
Okay.
And that prevents any unauthorized access to the rear of the machine where there might be other hazards.
Right.
And the relevant ANSI standard there is B11.4, which covers the safety requirements for power presses and shears.
Wow. We have covered so much.
We have.
I mean, we've gone through a whole list of these different machine guards and shields.
A lot of different machines.
Yeah.
A lot of different hazards.
And, you know, it's just so clear that each one is specifically designed, you know, engineered to address those unique hazards of each machine.
Yeah, and I think if we try to kind of pull out some of the key takeaways, there are some common themes that emerge.
Yeah.
You know, the use of those transparent polycarbonate panels, that's so important because it allows the operator to see the work, but it's still providing that physical barrier.
Right.
And then those safety switches, you know, they're frequently integrated into those guard designs to immediately interrupt power or the machine's function if a guard's opened or some kind of hazardous condition is detected.
Yeah.
And then the other thing that I noticed was that consistent referencing of ANSI standards across all those different machine types really underscores that fundamental importance of adhering to those established and recognized safety guidelines.
Yeah, that's a great point. You know, and I thought the bypass key for those specific secondary lathe operations was a really interesting example of how safety can be balanced, you know, with the practicalities of the job.
Exactly.
And then, you know, the fact that some guards, like those on general shop presses and certain bandsaws, might not incorporate those safety switches. I think that really highlights that, you know, risk assessment is a nuanced process.
It's not a one size fits all.
Yeah, it's really about what's the most effective way to mitigate that primary hazard for each machine.
And I think what's really insightful here is recognizing that these safety solutions aren't just about bolting on some generic cover.
Right.
There's a real deep understanding of the machinist's workflow. The specific hazards at each stage of the operation and how to design guards that are both protective but also practical and don't hinder the work unnecessarily.
Yeah, it's not just about, you know, stopping the work.
Exactly.
It's about making it safe.
Making it safe to do the work.
Yeah. So for you, our listener, you know, considering the huge variety and that specific nature of all these different guarding solutions, it really prompts an interesting question.
Right.
You know, what other areas maybe beyond those traditional machines within the modern workplace could benefit from that kind of detailed and user-centric approach to safety?
It's a great question.
You know, thinking about other potentially risky environments or tasks.
You
know, could this level of focus, could this level of design really spark some innovation in how we protect, you know, individuals
absolutely
in all sorts of work settings? It's definitely food for thought. Thanks so much for joining us for this deep dive.
Thanks for having me.